actually in many ways wonderful, because I'm going to take you back for a much simpler question, whether we can make meat in the laboratory. And you would immediately say yuck, and that's the response of many people who will try to convince you that it's actually required to do so if Bert has not already done that job for me. So, you know, it creates all sorts of imaginary names, Frankenburger, Lab chops, factory pork. But in fact, it's really required to start working on this principle, because now we use, of course, pigs and cows, and they are very inefficient in converting edible vegetable proteins into edible animal proteins. And we all eat meat, and we continue to eat meat. And in fact, the World Health Organization has estimated that by 2050, the meat consumption will have doubled. And that's primarily, of course, from other nations. And right now, we're already using 70% of our arable lands for meat production through livestock. So you can do the math very easily. That's not sustainable. The other reason why we want to get rid of the livestock is that it is environmentally very cumbersome. Cows produce 39% of the methane, one of the greenhouse gases, and together the livestock produces about 40% of all our greenhouse gases. So, which has sort of led to the expression that a meat eater with a bicycle is actually much more environmentally unfriendly than a vegetarian with a Hummer. There's another reason. There, of course, are a number of other reasons why you want to get rid of the livestock. That's because we all know that it's, the bioindustry is sort of animal unfriendly. These are these calves that have no space, have no sunlight, because their flesh needs to be white, because we export it to Italy and they want white veal. And the fourth reason is that there are zoonoses. We all know that here in this area you have Q fever, and that's one good example, and it's a result of intense herding in the bioindustry. So the concept is actually very, very simple. We don't make life, we already use life, a cell, a stem cell, from the muscle of an animal. You have many stem cells, also we have many stem cells in our muscle, and you can actually take them out of a muscle, and you can grow meat from it in the laboratory. And these cells, since they are stem cells dedicated to become muscle, nothing else, they proliferate. So from one cell right now we can make 1 million and sometimes 1 billion, and those cells in the lab, more or less by themselves, start to become skeletal muscle tissue, which is the basis for meat. So it's actually a very, very simple concept. Here you see that cell growing out of a muscle fiber, and you can, right now it can undergo 20 doublings. So we can make, and actually this work is also done at the University in Eindhoven, we can make strips of muscle. Can you repeat that one? We can make strips of muscle out of this, and we can actually, it starts to move. And we can electrically stimulate it, and it starts to move even more vigorously. And of course, that's at some point required. Now, we start with these very simple strips of scaffold, of Wim van Hanegem called it Hugaveld tapijt. And we grow skeletal muscle on those strips so that you get a 3D structure. And of course, also, this doesn't come for free, so you need to add sugars and proteins and fatty acids. But the thing is, you can play with it. You can make it much more efficient than a cow or a pig can do. So we can increase the efficiency of this process, and that's where our gain actually is. And we potentially also could tweak the feeding of these cells in the way that it becomes a more healthy product. Or we can use algae soup. As Bert has pointed out, the sun together with some nitrogen and CO2. We take CO2 out of the air through a process called photosynthesis, produces sugars and eventual proteins. We can make a mix of that and give it to the skeletal muscle. So we also need to condition that meat to make it more firm, so it stretches. We stretches our muscles, that's healthy. It beefs up the muscle. And we can also electrically zap it to produce strength. It's called the gym in the laboratory. So of course we have other tissues than skeletal muscle. We can also make those. We can make bones, no problem. And eventually we envision, it is an artist's rendition of course, that we have a production of meat around these center bones and a circulating system around it. And this would be the entire factory with an LJ pool and a cell culture system and all these units where these are being produced. We did some life cycle analysis, and it shows that we can, with all sorts of assumptions, that we can reduce land, water, and energy consumption, and this is what it eventually would look like. And of course, it also relieves our conscience when we eat meat. Finally, there are a number of challenges, which I won't go through, it's not ready yet. But finally, the problem will be what is the remaining role of the domestic animals, and I'm sure you can agree with me that this is a much better state of being than on a barbecue. Thank you very much.